All right. This is what we did yesterday. So this is basically section 2.7. You got a rational equation. You have different rational parts to that equation. I've asked you to solve it. And the way that we did that was we said you could find common denominators, get them together, cross multiply, or you could clear the fractions. Those are the two primary methods that we use. And I don't really have one reference over the other, but I think that you will find clearing the fractions easier to do because there's less work. It's quicker to get to the solution. So if we work this out, the first thing we want to do is divide, or not divide, but to factor the denominators if I need to. When I factor that, I see what all the elements are, and when I go to make my common denominator, I keep each element that shows up in my denominator, only just one time each. So then we can go through, we can multiply each fraction by that denominator, just one on the top, and we see which cancels out, because my goal in this case is to get rid of the denominators. So I can multiply by something so that when my pieces cancel, you get all of the parts to cancel out, and we're only left with our numerators and the products of the pieces that were left. So you end up with that part, x squared minus 5x plus 2x plus 4 equals 14. And the next part would be to go ahead, combine your like terms. At this point, you can already tell me no solution, because that is the same as that. So when I go to factor it and solve for x, hey, wait a minute, that's the denominator of this side. So no matter what I get for this, it means my zeros are going to be undefined. But let's just go ahead and finish it out. Once you factor that, you realize that there's my zeros, but we go back and we find our restricted values. This is something that should take place. I don't care if you do it at the beginning or at the end. You should always find the restricted values just to make sure that what you didn't actually give you one of your asymptotes. In this case, both values that we found were restricted, which means there's no solution to the problem. If I were to graph this equation, if I were to graph either side, the question is, when is this side equal to this side? So if we're looking at the graph, what do you know about this particular, this would be graphing two pieces, two different graphs. What do I know about this? No. Because I got two, it's not equal to 0. If it was equal to 0, then yes. But in this case, I have one expression equal to another expression. They don't ever intersect each other. They're completely separate. If it was equal to 0 and you get no solution, what that means visually, it means that they don't ever touch the x-axis. If you have one equation equal to another equation, that would mean if you get solutions that exist, that's where those two things cross each other, where they exist in the same location on the coordinate plane in general. But this one doesn't enter it at all.
So are these like parallel?
Well, no, these are kind of all over the place. It's probably what would happen is if I didn't have asymptotes, they would touch each other where the asymptotes exist. But because I have asymptotes, they go off to infinity instead. Okay, I haven't actually looked at the graph, but that's what it would be. Any questions about that? That's really, in a nutshell, in one problem. That's what we did yesterday. That's what I want you to walk away from yesterday with. This kind of problem is really typical of what I'm going to give you on assessments. Gio?
If you did it the other way, when you subtract 14 over x plus 2, x minus 5, it cancels out the x plus 2, x minus 5.
Even if you did it the other way, you should still get no solution. Either way. All right, so what I'm going to do next, any questions before we move on? All right, wake up. Okay, let me back that up. Shh. Pay attention. Pay close attention. So here we go. This is going to be, you're going to see a lot of things we've talked about come kind of back into play a little bit. So what I want to do is I want to be able to, I'm going to break it down. So we're kind of starting halfway through the problem, because I want to do the new part first. Then we'll go back and work an example from start to finish. So once I've got an expression that is factored apart, I want to know where is it positive or 0 or negative. In fact, I want to know where all those things happen. And so the way that we're going to do this is, I could graph it. Okay, that can be trouble if I don't have a graphing calculator, so we're not going to do it that way. What we're going to do first is we're going to take our zeros and put them on a number line. So you see up there, zeros. I'm going to give you just a few seconds, and I want you to draw a number line, and I want you to put the zeros down real quick. What are my zeros? -3. And, oh, really?
No, it's plus or minus I.
When you solve that, x squared plus 1, when you solve this for 0, set it equal to 0, x squared plus 1 equals 0, what do you get? X equals plus or minus I. Can you find I in the x-axis?
No.
So it's not a real 0. It would be a root, yes, not a 0. So that doesn't get labeled. Positive 4 gets labeled. So let's look at it. If I put it on the x-axis, this is what it looks like. You've got -3 and you've got 4. The I is imaginary. So what that would mean is if you're graphing this, it's going to go through the x-axis here, it's going to go up, it's going to curve right here, but then it's going to go back and touch the x-axis again here and bounce back up. That curve in the middle doesn't touch the x-axis, so it doesn't get labeled. Gio? But it's the same number. It means it bounces off the axis right there. That's positive 4. Set it equal to 0. X minus 4 equals 0. Add 4 to both sides and you get x equals 4. Doesn't matter. That just means there's 2 of them. Double root, same thing. So you can put, if you want to put 2 circles at 4, you can. Doesn't matter. Just solve it. The exponent really doesn't make a difference on the different zeros. We're just graphing the different numbers that occur. You set each of those factors equal to 0. And that shows you where it crosses the x-axis because it's factored. Okay? Next, we're going to break up that axis into 3 sections. You'll have one more section, then you do zeros. Since we have 2 zeros, we got 3 sections. We'll do one in a little bit where you have 3 zeros, and you have 4 sections. You can look at the TV, it's a lot clearer up there. Okay, so the next part, step 2, we've got to pick a point from each section so that we can test to see what the result's going to be. This is easier than at first part, right? So what we're going to do is I'm going to go through each section. So we've got the section here, the section here, and the section here. And I'm going to go ahead and pick a number from each one of those sections. 0 is always a nice one to pick because it's the easiest to think about. The other ones just kind of happen to be whatever you want them to be. The only thing you're not allowed to do is to pick something that exists on one of those critical points, the zeros. I can't use zeros. So if 0 was a 0, then I can't use it. Okay? The next part comes, and I'm going to do one kind of, I'm going to take it apart and do it literally. The rest of it I'm just going to do in my head because I don't need to work out the problem. I just need to know the signs. So I plug it in, oh, that gives me a negative, and I'll record that part. But I'll show you what I mean to start with. Okay? Step 3 is what we're going to do is we're going to take these points one at a time, and we're going to plug them back into our original part. I have 3 pieces, right? 1, 2, and 3. I'm going to take each one of these numbers, and I'm going to plug it in. And what I'm going to record is the sign of each number that I plug in. Watch. So we basically plug it in, and the part that I wrote down was, well, 0 plus 3, that's positive. 0 squared plus 1, that's also positive. Okay? But 0 minus 4 is positive. Why? Because it's squared. 0 minus 4 squared would be positive 16, right? So it's positive. So I only really need to know the sign. You can go through the process and write the numbers down to record the actual products, but that's a little bit overkill. really what I needed to know was if I multiply all those things together, am I going to get a negative number or a positive number? Since each of those values were positive, positive times positive times positive, it's positive, right? That's what you get right here. So we do products, positive, 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 you get a positive. How do you know when it's going to be negative? How many negatives? Give me a general idea. Don't use numbers. When there's an odd number of negative signs. 1 or 3, okay, or 5, depending on how many I have. In this case, I either have 1 or I can have 3. That would be the only way to get a negative one. When you have an odd number of negative signs, it's always going to end up negative. So what we're going to do now, all right, check to see if this is what you got. Should have got a positive, positive, positive when I plug in 5. That was pretty obvious. When I plug in negative 4, the first one is negative, but the rest of them are positive primarily because I'm squaring each of the parts, so it really doesn't ever become negative. And so the only negative section is the part that's less than negative 3, down on this side over here. And then in between, you have positive in between negative 3 and 4, and the positive where you have 4 is greater than, or x is greater than 4. Okay? So I could ask, let's go back a minute. What are the questions I could ask you for something like this? The original problem could look like one of these two things, where I give you the f of x, and I say, well, where is f of x less than 0? Or I could say, where's f of x greater than 0? And these are the two ways you'd answer that question. Where's f of x less than 0? The only place f of x is less than 0 is over here. Right? This is the negative section, so it would be from negative 3 back to negative infinity. So your interval notation would be from negative infinity all the way up to 3, or your inequality would look like x is less than 3. I want you to get used to using the interval notation. Okay, that's the answer. That's the way I expect it to be written. The other side would be what? How many sections do I have? Negative 3 to 4 is one section, and then 4 to positive infinity is the other section. Good. Why can't we say negative 3 to infinity? Because 4 is 0. That would not be the case. So you got to skip over 4 because it's broken. So you'll have to do that for every section you have. It's a different interval notation. You're going to have to break those apart. X is less than 3. Oh, that is negative 3. My bad. Let me fix that. No, good. So this part should say negative 3 here. No brackets. No brackets because we don't have any equal to parts. Okay? Any questions on that? That's really, that process is the new process that we're going to be doing for this. Any questions about that piece? Oh, did I do that?
Why did you write negative 3 to 4?
Because this part, if you look over here, from negative 3 to 4, it's also positive, right? The question was, where is f of x greater than 0? Where is it positive? Well, between 3 and 4, and from 4 to positive infinity. So those are the two sections. Because it's broken at 4, I have to write both intervals, because 4 would be equal to 0. And in this case, I can't just include everything. I got to skip over the 4. Does that make sense for everybody? All right. So I'm going to give you another one. And this one's going to be all together. So I'm just giving it to you to start with. Go. Okay. Little clue. Try synthetic division with 4. Just to speed things up. All right, let's keep on going. Shh. Look at the screen. Shh. When you do your problem, you should get something that looks like this. Right? First thing we talk about synthetic division. Now, on an assessment, I wouldn't give you the little hint. I would expect you to try P over Q and try a couple of problems, and you'd get one number. That's all you got to get, one number. Probably would have gotten -2 first if you try the ones and -1s and 2s and -2s. That's the direction I would have gone. Then, because it's cubic, right? Because it's cubic, I'm only going to find one root, and then I'm going to take the resulting equation and rewrite it as a quadratic and factor. Okay, once you factor, the 2x squared breaks into 2x and x. There's really no other way to do that part. 6 has a couple of versions, right? And so I think, well, 2 times 6, if I multiply a times c, I get -12. How do you get 12 has factors of 1 and 12, 2 and 6, and 3 and 4. Which of those could give me a 1, 3, and 4? So when I put my numbers down here, I want to get a 4 and a 3. So that gives me 3 in the middle and 4 on the outside. So you get 4 minus 3. Did I just blow some of your minds? Anyway, when you factor and you solve, you get that done. Next step, putting it on the number line. Since we got 3 halves, -2 and 4, I'll put those on the number line. Easy enough. I'll break those sections up and pick a number in each section. -3, 0, and 2, and 5. I'm going to plug each of those numbers into my equation. However, I'm not going to plug it into my original, because if I plug it into the original equation, I have to work it all the way out. Probably going to have to get my calculator out to do that. Right? Or it's going to take a while. We want to rewrite this as a factored form. Well, what are the factors of this? I already got 2 of them written right there. What's the third factor? Well, the root is 4. The factor would be what? X minus 4. So let's go ahead and rewrite that in the factored form. Then the only thing I have to do is plug it in and see, is that positive or negative? Is that positive or negative? Is that positive or negative? Once I've got that down, I can go ahead and figure it out. If I plug -3 into my equation, that gives me a negative value here, a negative value here, and a negative value there. Odd number of negative signs makes this whole section negative.
I thought you said you plugged it into the original equation.
I did. The factored form of it.
Oh,
That's why I just got, shh, back up. Watch, look. If you plug it in up here, shh, listen. If I plug it into the original form, I have to work it all the way out. I really don't want to do that. This form and this form are equivalent. In other words, if you plug it into either one, it's going to give you the same answer. But because this is already multiplied together and it's really easy, it's linear pieces, I can do these mostly in my head. So I can plug it in here. That's why I said use the factored form, not the cubic equation at the top.
But it is possible.
You could definitely do it.
Because what if you use the -b plus or minus square root instead?
That's not quadratic, so don't do that.
You still get the same answer.
No, you don't. You can't use a quadratic because I'm not plugging this. Listen, guys. Shh. I'm taking these values. This was -3. I'm going to go back up here, plug -3, and there, and work to see what I get. But I could also do it here. Why would you?
I'm talking about where it says 2x squared plus x minus 6. Instead of factoring it out, can't you just use that formula?
No, because that is not that. You're missing this factor. You must use all 3 factors or use the original equation. Okay? Let's look at the rest of them. Okay, now, listen. Who needs clarification on how you get the signs? Do you understand how that works? Grace?
yes, I understand.
Do you? You were whimpering earlier. I didn't know if you
See,
were.
I use the quadratic form as well.
Yeah, it works perfectly. I don't know.
It doesn't make it.
Let's go ahead and finish the problem. Factored apart. The question was originally, when is this equation greater than 0? Well, the two positive sections, I highlighted those up there in red, are negative 2 to 3 halves and positive 4 to positive infinity. Okay.
Don't erase it yet. Hold up.
I gotta go on.
I'm sorry.
Gotta go. Yep, gonna go. All right. Shh. I'm gonna give you a few minutes. X over x, or 5 over x plus 3 plus 3 over x minus 1 is less than 0. Actually, I'm just going to do this because we're running out of time. So watch. Let me caution you. This is a little bit different than clearing my fraction. I don't want to do that because I don't want to know just where it's equal to 0. Clearing fractions allows me to find zeros without a doubt. Okay? Real quick, right to the point. I can do that to find the zeros. Write this down. In order to do the inequalities with rational expressions, with the fractions, you're going to have to do this. Okay, you're going to have to find the zeros. Yes, I need those. But I also need the vertical asymptotes. Okay? Vertical asymptotes and zeros. I need both of those things. That's why this part is a little bit different. So here's what we're going to do. I'm going to go ahead and I'm just going to put those together in a common fraction. So we're going to find a common denominator and work those out. So it looks something like this. Right? We're going to multiply this side times x minus 1. This side x minus 1. No, x plus 5 on this side. Okay?
Why'd you do x plus 5?
Oh, I mean 3, sorry. Done this too many times. So it's that new math. We just make up stuff. I know, right? So, we'll work these out. We're going to get 5x. We're going to get 5x minus 5 plus 3x plus 9. It's all over x minus 1 times x minus 3.
You always forget to close your bracket.
That's still less than 0. I'm going to go ahead. I'm going to simplify this part. That's just going to give me 8x plus 4. I'm going to leave the bottom part factored because I'm going to need that. So far I haven't done anything out of the ordinary.
Why is it minus?
Yeah, it's plus. Okay, so what are my zeros? How do you find those zeros? Take the top part, set it equal to 0. And so we end up with x equals negative 1/2. To find the vertical asymptotes, what do? Set the denominators equal to 0. So x minus 1 equals 0. And x plus 3 equals 0. So we have x equals 1 and negative 3. Okay. Yes?
When you put the denominator, why didn't you multiply x minus 1 times x plus 3?
I didn't want to do that because I was going to have to turn around and factor. So I would still have to pull it back apart. So don't ever do it. I left it factored because I needed to have it factored to get out what's important and to do the next part. I did multiply the bottoms by that. It's just the same bottom. So you keep the same denominator and you put it together. Okay? So the next part's my number line. So we're going to go in. Here's 0. Let's go ahead and put in. We have positive 1 we have negative 3, and we have negative 1/2. So when you got these values,
Negative 1/2 is a 0, not just an asymptote.
negative 1/2 is a 0, yes. It's the only 0. In this case, I don't really care what they are. I know that something's happening there. So it breaks up my graph into sections. Right? So we have 1 section, 2 sections, 3 sections. Right? So this part, let's label the numbers. We have negative 3, negative 1/2, and then positive 1. Shh. This is actually less work than the one we did before. So take your numbers. Let's pick something in between each of these values. So we'll pick, I like 0 in here. We'll pick 2 over there. Let's pick negative 2 and negative 4. So those are the values I'm going to pick. I'm going to plug those in, but wait a minute. Where do you plug it in? The factored form. We're going to plug it in right here. Okay? Because it's easy. I don't want to go back up here because if I do it up top, I'm going to if I did it there, and I could, but I would have to plug it in, work it out, add them together, and see what I get. Rather than just writing the signs down because it's all multiplied or divided. So let's plug in 0 since that's the easier one. So we'll have 0 plus 4 over negative 1 and then 3. So that really means it's positive over negative times positive. Do you see that? So the top part's a positive 4, then it's a negative 1 and a positive 3. So really what I'm interested in looking at is the fact that that's a positive, a negative, and a positive. So what is that going to give me? That would make it end up being completely negative. So let's put a negative where 0 is. So this would be a negative total. Okay, let's plug in let's just start with negative 4 and go across. So if I plug in negative 4, right? Negative 4 on top makes that negative 32, so it's just going to be negative. And if I plug in negative 4 on the bottom, it'll make it negative. Negative 4 on the bottom there makes it another negative. So negative 4 is negative because it's an odd number. So negative there as well. When I plug in negative 2, what do you get? So negative 2, we plug it in here. Negative 2 would be negative on top. The negative 2 would be a negative on the bottom for the first part. And then negative 2 there, that'd be a positive. So negative 2 actually is a positive value. So we put a positive there. And we're running out of time, so I'm just going to go ahead and tell you the rest of it. When I plug in positive 2, it's going to be positive as well. Okay? So the original question was, when is this less than 0? So what's my interval solution? Negative infinity to 3 and negative 1/2 to positive 1. So those are the intervals such that the whole equation is less than 0. Or if I graph it visually, if I look at the curve, that's where it's below the x-axis. Positive would mean where it's above the x-axis. Okay? Any questions about that?